Thank you, Alicia. So let me set some context for the demo today. Demo is about the Member 360 for Medicaid Enterprise System MES Data Hub. Today, many states in US are undergoing the modernization of their legacy Medicaid Management Information System (MMIS). And for this initiative, they take modular approach for implementation, which is the good approach for modernization program, but it leads to lack of integrated and consolidated information across different modules such as member enrollment or patient enrollment, provider management, claims management, etc. Not only that, but sometimes there are multiple sources feeding data to the same module. For example, there could be multiple sources for members, provider entities, leading to duplicates, incomplete, and inconsistent information about such entities. So in the demo today, we'll see how MarkLogic simplifies such complex data problem with its Data Hub solution and helps states to achieve their goal of unified, accurate, and 360-degree view of their member data to improve the patient outcome, reduce the member care gaps, and improve the quality and access of accurate data to the stakeholders. So now let me talk about the demo dataset before I jump over to the demo. So as Alicia mentioned, MarkLogic is a multi-model enterprise NoSQL database which can ingest data from any system in any format as is without any upfront schema or a data modeling required to ingest the data. And to demonstrate this, I have few examples of different data formats for this demo. So what I have here is the member data from MMIS system, which is relational system, and data is in the CSV format here from that system. And I have member coming from another system called Curum, which is in the XML schema. And as you can see, though both are data about the member, but both are in a different schema, different format. And in fact, the CSV format is quite flat schema versus XML is, as you can see here, deeply nested hierarchical schema. And to add to the complexity, I also have the member ID card, which is picture, image, PNG files. So the point here is that MarkLogic can ingest all of this heterogeneous data from various systems in different format without any upfront schema or a data modeling, and we'll see that in a demo soon. So with this context in mind, let me get over to the demo quickly. So I'm logging into Data Hub Central UI here. And what you see here is the Data Hub Central user interface. So this is the user interface MarkLogic provides out of the box for developer to develop the Data Hub in development environment. And of course, you don't use this UI to run or manage the Data Hub in production environment. In production environment, you may use the enterprise job scheduling or orchestration tool, and MarkLogic provides the API to integrate with such orchestration tool. So what you see here are the 5 main steps in order to build the Data Hub. So first thing first is to load or ingest the data, model the data in the entity model, then do the curation, mastering, mapping, and once the data is curated, mastered, you explore that data, and run is to run all the data flows and the mapping steps. So we'll go through each of this in detail as we go through the demo. Okay, so let's look at the load step and ingest some data. So what I have here is the load step for my MMIS data in CSV format. and uh, ingest step for the QRAM data, which is in XML. We'll look at both of them. So the configuration step for the ingesting the CSV is very straightforward. The ingestion in MarkLogic is very simple as is. So you just define what is the format of the source data. In this case, I have a CSV input source. If it is CSV, define the field separator, and then once the data is persisted in MarkLogic, how you want to persist that data. So in this case, though my source is CSV, I'll be persisting that as a JSON document, and then provide the source name and the type of the source. So that's pretty much the basic configuration to ingest the data. For the advanced configuration step is basically providing some more information about the data lineage and data provenance in terms of the source and lineage information here. And if you have some pre-processing or a post-processing needed, then you can define that as an interceptor step. So that's pretty much the configuration to ingest CSV data. And in order to ingest the XML data, it's pretty much same. I'm just defining the source as XML instead of CSV, and pretty much ready to ingest the data now. So I'll run this step to ingest the MES data. I go select my data, which is in this folder, the CSV file. And I'll also ingest the QRAM data, which is in another folder. I can select all of them together. So now whatever is ingested is now ready for me to explore. So as I mentioned before, MarkLogic index everything whatever is ingested, and it's immediately available for me to search and explore because MarkLogic comes with a built-in index and search engine. So I'm exploring the data what is being loaded. So if I search like a Google like a search, full text search on name Muhammad, and if I just filter on my CSV and XML source, I find two instances of Muhammad here, one from the QRAM XML data and one from my CSV JSON data, and I can look at both of them. So the data which comes from the QRAM XML, the record looks like this, which is, as I mentioned before, very deeply nested hierarchical structure, XML structure. And if I look at the same Muhammad, the record coming from MES as a CSV source, CSV record gets converted into a JSON key value here, and has all the other information about the metadata. So the best thing in MarkLogic is the metadata stays alongside the main data. So it becomes easy to refer to any metadata, like when was this particular record loaded, who loaded it, and what is a collection, what kind of security is applied and permissions are required in order to access the data from this document. So all of that stays along with the document. Metadata and data stays together. So what we have seen so far, the key takeaway from what we have seen is the ingest is as is, and as you would have seen, I didn't create any schema to ingest this data. So that's the major differentiator compared to the traditional relational ETL based solutions, because imagine if I had hundreds of such data sources to be ingested all in different formats and schema. then it would have taken at least a couple of days or weeks worth of work to create all the schema and then ingest. In MarkLogic, I ingested all of them without creating any schema. So that speeds up the integration work at least 10 to 12 times faster than traditional relational ETL based solution. And the other best thing what we have seen is that everything is indexed, whatever we ingest. So that makes the data immediately available for business users to search and explore. Okay, so we load the data as is in MarkLogic, but we don't want to keep it as is. So let's see how we can model and then map it, curate it, transform and enrich that data. So modeling in MarkLogic is done with the data first approach, keeping that approach in mind. Meaning what you want to do with that data, keeping in mind what business problem we are trying to solve. We start creating this model. We call it entity relationship model. So we create a bunch of entities, what is needed in order to solve a particular business problem, and then establish the relationship between those entities in the business context. So the entire approach is very iterative, and you can evolve the model over a period of time. So you don't have to model all at once from the source, and you can do it in an iterative fashion. So in this case, for this demo purpose, I have an entity created called member, and member has sort of a self join to itself, meaning primary member can have more dependent members like spouse or children. Then member can have one or more claim. So member has claim. That's how the relationship is defined in a business context. And then claim has the claim item, and claim item has the provider, and then provider has affiliations with the hospitals, and provider is operating from several service locations, and provider has associations with the institutions or organization. So the point is that as you can see here, I don't have to have all the entities and the relationship done all at once and map all the source attributes from a particular source system to this canonical entity. It can be done in an iterative fashion. So as we create these entities and the relationship here on the UI, behind the scene in background, MarkLogic Entity Service is creating SQL views, TDEs, for these entities and the relationship, and that's what is going to give us the connected data or connected information between this entity using this RDF triples. So we call it semantics. So that's the magic of semantic in MarkLogic to get the connected information or a knowledge graph. And we will see this when we explore the data, how we are able to explore the data exactly the same way, the way we have modeled it here. So the other thing is for each of this entity, once we have entities defined, we can then define the attributes for these entities. So for example, for the member entity, I have a bunch of attributes defined here. The best part is that these are all the attributes of canonical entities. So you can use the enterprise standards for each of these attributes in terms of how you want to call out names or address or SSN sort of attributes. So that way, consuming application, it is a consistent way of accessing this information, no matter what it is called in the source system. It remains consistent here in this canonical model. And for each of this attribute, you can define all the data types. So there are all the standard data types available in MathLogic to define a particular attribute, and also some of the advanced data type like array. So attribute can have multiple value in the same record, which is very powerful. Not easy to do it, or not even possible in relational to have multiple values in the same record. And if needed, attribute can be referring to another reference structure, another entity as a reference structure in attribute. So that's very powerful way of defining the attribute. And in terms of some of the advanced setting for those attributes, you can define attribute as PII, personally identifiable information. So that way you can use this attributes for doing element level security, or use it for redacting this information when you are sharing it. So SSN is very sensitive, and when you are sharing the information about member with the external agency or within the department, you want to redact this information while sharing, and that can be done once the attribute is defined as PII here. So that's pretty much how we define the model here in MathLogic. And then next step is, once we have model, we'll see how we are able to map the source system attributes to this canonical target entity. So we'll look at the curation step as the next step. Okay, so let's look at the curate step now and see how we can map, transform, and enrich the data in MathLogic Data Hub. So I'll take this member entity example, and we ingested the MES data, and now it's time to map it. So let's look at the mapping step. So in terms of the configuration, you define what the ingest collection you want to use to do the next step of mapping that data. So obviously referring to collection load MES. And then if you look at the step details, so what you see here on the left is the source data from our CSV, and on the right is what you see is the target member entity as we define in the model. And now we can one by one map those this target canonical model attributes to the source attributes. So all the source field are available from this drop down, and you can select what source you want to map it to this particular attribute. So in this case, SSN is mapped to SSN. While mapping, if you need to do some sort of transformation, so for example, full name, there is no full name in the source, so I'm concatenating first name and last name and making it as a full name with space in between. So this kind of inline transformations, you can do it with hundreds of out of the box mapping functions available for each type of data, whether it's a string or a date or a numeric data type. There are a bunch of mapping functions available for each of this data type. And if those are not enough, and you need to have custom mapping functions. So for example, I'm normalizing the address line here, address line 1 and 2. I'm normalizing using some parsing rules. So you can create those kind of custom mapping functions as well if you need to do some more advanced transformation. So that's pretty much how you map each of this canonical target entity attributes with the respective source attribute, and do some inline transformation as needed. We'll look at some more mapping example just to give you idea of what other things can be done. So for example, I was talking about lot of out-of-the-box mapping functions available. So there is another function called lookup, document lookup. So that brings you the value based on some reference data. So in this case, there is a diagnosis code in ICD 10 code, and I need the description for that code, and I can do the lookup to that ICD code reference data and get the value. So this is how we do the mapping and transformation and enrichment of the data. And now let's run those steps. So I'll go to run member, and I'll run my MES steps. And also run the QRM. So now the data is ready for me. It's curated, transformed. So we can now explore the same data the way we modeled it. So if you remember the way we model the data, we will be able to explore it in the same connected fashion. So for example, if I search on a member named Rindy, and here what we see is that this data about the Rindy. So I just search on the member Rindy, but as you can see here, I'm getting all the connected information about the member Rindy. So in this case, member Rindy has this claim 1001, and as you can see, this claim is now getting attributed to 3 different instances of the Rindy with the I in the first name, and Rindy with the Y in the first name, and the flipping of the first name last name in the name. So there are multiple instances of Rindy with some variations in their first name or a last name, and that is causing this duplicate instance for member Rindy. And then this member Rindy has 2 dependent members, Nuno spouse and Nuno Junior as a child. And then this claim has a claim line item. So the point here is that we are able to see this data exactly the way we modeled it in a connected fashion, and that is the power or magic of semantic in Mark logic, which gives us all this connected information about the entity and the relationship. So now we while exploring the data, we realize that there are some duplicate data issue, and we need to resolve this. So we'll again look at the curate step or the mastering step rather, and see how we are able to use the out-of-the-box mastering capability in Mark logic to do the matching and then merging and resolve this duplicate issue. So if we look at the mastering step, there are 2 configurations for the match and merge. So in this case, it's a configuration driven match step and the merge step. And in the configuration, you basically define 2 things. One is the match options. So what are all the attributes you want to use in order to identify that a particular record is a duplicate record. So in this case, member as a person data, obviously you will use the first name, last name, SSN, address, email address, telephone number, etc. to determine whether the particular record is a duplicate or not, based on the attributes and the weights of each of these attributes. So in this case, SSN has the more weight, because if that matches, then it has a more weight. And then likewise, we have defined the weights for the various other attributes, address and name and such, and date of birth and all. And then the kind of match what we want to define is also configurable. So in case of SSN, we are using the exact match, but you can also use out of the box matching algorithm like synonym, double metaphone, zip, reduce, and if those are not enough, you can have your own custom matching algorithm also. So in case of first name and last name, we are using double metaphone so that if there are some name sounding alike, also will be then considered as a match with the score of 10 and 6. So once we have defined all the matching criteria algorithms, we then define the action, what action we want to then take based on the match score. So if we have a total score of 60 plus, that means it's a definitive match, and we want to do auto merge of those records. If the score is not that high but somewhere in between, and that could be a potential match, then in those cases we don't want to do auto merge, but we want to notify the data stewards to look at those potential match and then decide whether to merge or not to merge. So those are the two match action based on the threshold you can define. And once you have defined that, you then define how you want to merge those duplicate records. So in some places you want to have a particular attribute value from the more authentic source. So in case of example here for SSN, if there are duplicates across the system, then we know that SSN defined in MES is more authoritative than QRAM. So we give more weight to MES, and that way if there are duplicates between these two systems, the merge record will have a value from MES. And likewise, you can define the merge strategy, how you want to merge. You can also have both the values from the duplicate source maintained as a multi-value, because as I mentioned, you can define the attribute as array, and that allows you to store both the values from the source. So that's pretty much the configuration driven match and merge step, and we can now run those steps and see how we are able to resolve those duplicates. So I'll go mastering and run the match step, and also then run the merge step so that we can then look at the data and see if it is resolved. So mastering is done. Let's go back and look at the same Drindy again, and boom, as you see here, it's resolved. Instead of 3 Drindy instance, I only have 1. And as you can see here on the right, when I click on this, I get the full detail about that particular entity. So in this case, now Drindy member entity is a mastered entity and has all the 3 duplicates now available in this golden record, master record. And it has all the information, as I mentioned before. Okay, what are all the original duplicate records are merged into this golden record. The URI of those records are also maintained in the same master record. And then we have more corrected information, as I mentioned before. But now while looking at this, we also realize that the 2 dependents also got wrongly merged based on some of the criteria having higher score. But we know that this Nuno are 2 different person. They are not the same. One is spouse, one is child. So we need to unmerge this. And unmerge is very simple, very easy in MartLogic, because as I mentioned, MartLogic maintains all the merge history. So we know where this record came from, how this record was merged, and all the merge history as well as all the metadata is maintained. So that way it will be very easy for me to unmerge. This otherwise would have been very difficult even in the sophisticated MDM tool to do this kind of functionality to unmerge. So here it is just a click of button here to unmerge, and I have my 2 Nuno records back. The other thing is as I mentioned, the way we define the model and the relationship. I can get more expanded search now on this and get more information about this member Drindy. So I know that she has one claim and one claim line item, but I want to know who was the service provider for this particular claim. So I see Dr. Jacob, and I can find the information about that doctor here on the right. I can also expand further and see what hospital that doctor is affiliated to, and then what service location he's operating from, as well as what specialty he has. So I now know that this claim of Drendy about this particular line item is related to some urology issue. So as you see, I just searched on term Drindy, but now as you can see here, I get a full 360-degree view of this member Drindy with all the information about the dependent members, claims, and the provider, as well as all the information related to that provider as well. So this is because of the semantic capability in MarkLogic. We are able to see the data the way we modeled it with all the knowledge graph about a particular entity based on the semantic capability. So now that we have data curated, mastered, and available in the MarkLogic Data Hub, the next question is how do I access it outside of MarkLogic in some sort of a BI applications or some sort of a SQL based system. So we'll see how we can access this data through SQL views as well as in a BI tool like Tableau as a next step. So as I mentioned before, when we created the entities and the relationship between these entities in this model, behind the scene, MarkLogic Entity Service created the SQL views based on TDE, template driven extract, for these entities and the relationship, and then those are now available in the query console, which is the UI here, query console, to query the data in MarkLogic. And MarkLogic natively supports a variety of different languages: JavaScript, Optic API, XQuery, and SQL is also one of the natively supported query language with the SQL NSI 92 standards. So now I can run any SQL statement on my database. So select star from member. If I run that, I get all the member data from the SQL views. So MarkLogic also provides the ODBC driver to connect to any SQL based application. So using this ODBC connection and the SQL views, we can connect MarkLogic to any BI tools like Tableau, Power BI, or ClickView. So let me connect here to Tableau, and let's see how we can connect Tableau to MarkLogic and do some analysis. So in Tableau, as the various options to connect to different data sources, MarkLogic is one of the named connector out of the box in Tableau. So we can use this named connector to connect to MarkLogic. And then I have defined here the Tableau connection to MarkLogic using this ODBC driver connection. And as you can see, if I go edit the connection, what I have to define here is the port which is listening to this ODBC app server, and then the user credentials. So when I give this user credentials to connect Tableau to MarkLogic, the same security gets applied even in Tableau for the MarkLogic what has been defined to access the data. So now I'm connected to MarkLogic, and what you see here on the left are all the bunch of views which are available out of the box created by the entity services when we created the model. So all my views are available for me to access, and now as a Tableau desktop author, I can author any dashboard and report. So for example, I have created here a small dashboard based on our claim and member data. So as you can see here, before mastering the member, we had a lot of duplicate counts in each zip code, and after running the mastering, we get much cleaner count of the members by zip code. And then same way, this chart shows the claim amount versus the number of claims for each year. So you can generate this kind of analytics very quickly, very easily once the data is connected to or tool is connected to MarkLogic. The other example here is the geospatial analytics. So MarkLogic supports geospatial data natively, and also has an API to maps API like Google Map or Esri Maps. So here this is connected to Tableau Map API, and then using the geospatial data, we are able to create some sort of a geospatial analytics or a dashboard. So in this case, finding a doctor for a specific primary specialty in a geolocation, and also heat map of all the patient based on the disease. So we can see the patient population by disease geographically. So that's basically it for the end-to-end demo. So we have seen all the way from ingestion to consumption, how we are able to use MarkLogic Data Hub and get all the information. So just to summarize what we have seen so far is our data first approach in doing the entity modeling with keeping in mind what business problems we want to solve is very helpful, provides a lot of flexibility and agility in terms of how we model and how we solve the particular business problem. The other thing is we have seen with MarkLogic NoSQL ingest as is data from any format, any source system, along with the data governance and data security applied right at the time of ingestion throughout the data life cycle, and also ability to curate, that is mapping, transformation, as well as mastering. All of this capability built into one single unified platform, which is very unique to have all of this available in the single product. And then our ability to deliver the data look exactly like the way we modeled it with our semantic capability to see the data connected as a knowledge graph, and also the built-in search and universal index built into the product, which is also very unique. You don't need 10 different products to get all this different functionality. It's all built into one single product. And finally, our incremental enrichment in the integration approach. So you don't need to integrate everything up front. You can do it in an iterative incremental fashion based on what you need and as you need it. So all of this leads to faster time to result and cutting down the overall integration time by 1/4 compared to the traditional integration methods.